Mario.
Okay, now for these, you can go through all the work of finding the pHs, and that would make it maybe a little bit easier to think about whether they were basic, acidic, or neutral. But if we just look at the concentrations, we know high concentration of H plus ions is going to give us an acidic solution, and it has to be something that it would be higher than 1. What's that number? It would have to be higher than 1e to the negative 7th. So my smartboard is not working. I can't write it up here. But this is a much lower concentration than 1e to the negative 7th, so it can't be acidic. It has to be basic. Here we have to think about it kind of the other way around. Here we have a whole lot of OH because it's got a high concentration, so that's going to be a basic solution. Here, this is just a little bit above, but it is still above 1e to the negative 7th, so that would be acidic. And then the last one, which right at, because if the OH concentration is 1e to the negative 7th, so would be the H concentration. That is a completely neutral solution. Now, alternatively, you can go through the work of taking the negative log and finding the pHs. And if you have the pHs, it makes it easier. These are both above 7, so the basic. This is below 7, it's acidic. This is right at 7, it's neutral.
Can't you just go off the rest from the code?
Yeah, that's what I was explaining before. Just the biggest thing is you got to keep track. Are you looking at the H plus ions or the OH minus? If you get those screwed up, you're going to have it opposite. Okay. Now for these down here, we're trying to find the concentration of complementary ions. So here we have the concentration of the H plus ions. So we need to find the concentration of the OH minus. And we do that because we know, or by knowing that when we multiply those two concentrations together, we should always get 1e to the negative 14. Every time. So in every case, I mean, once you do it, it seems a little complicated right away, but once you do a few of these, you see, in every case, all you're going to do is take that 1e to the negative 14th and divide by the one that you know to find out the one that you don't know. So you divide 1e to the negative 14th by every single one of those, and you get those answers. Okay, any questions there? Okay. So here we had to find the pH. So we take the negative log of the concentration, but it has to be of the H plus ions. So here we can just take the negative log of this one to get 9.22. But here, if we take the negative log of this, that's going to give us the POH. So you can do that and then subtract from 14. Or you can just go back up here because in part 2 we found the concentration of H plus ions. You can take the negative log of that. So I made all of these the same, so it would be a little bit easier to go in between those. Remember, pH is always concentration of the H plus ions. So if you're given the OH concentration of the OH minus, you're going to have to do some technical things. Finding the POH and subtracting 14, or finding the concentration of H plus ions. And then once you have all the answers for number 3, the answers for number 4 are really easy, because we know this plus this one have to equal 14. So we can subtract each of these from 14 to get each of these numbers. Okay, and then for number 5 right here, in this case, we want to find the concentration of H plus ions based on the pH. And so we have to do the opposite of the negative log, and that's by doing the shift log, as you guys say, but taking 10 to the power of the negative pH. So 10 to the negative 6.3 gives us this concentration, 10 to the negative 4.5, and so on and so forth. And these are concentrations. I'm not sure what happened here, where my M's went. I'm sure they were there at one time, but you should have your units there. It is a molarity. You put units with your concentrations. pHs don't need concentrations because it's just a scale. It's just a way of comparing the concentration of ions. Saying, oh, this one's 6, and this one's 5. The 5 is more acidic. That's really all the pH scale is for. But we're doing actual concentrations, so we need to have your units with those. Okay, any questions there? Okay. We don't have a whole lot to talk about today. But what we are going to talk about are ways of measuring pH. Right, that doesn't work. Well, awesome. Not working. We'll type it. Okay, here we've got a little vinegar.
My book says it's acidic.
Vinegar does have acetic acid in it. And here we've got some pH strips. So a pH strip is a piece of paper that has a chemical that is infused on it that will change color based on the pH. So here, if we put that pH strip in,
I don't know what they say about vinegar.
okay, and I don't know, we'll get a stronger acid in the middle, it'll be a little more, but you can see it changed color slightly. So on the side of the pH strips, there's a thing that you can match up, and you can see that this has a pH of about 5.
Wait, can we explain if you want to do it so we can have
We could try some Mountain Dew, I suppose.
Yeah, I want to see how acidic that feels.
See, I don't know.
See how bad it put in my body.
I don't know that I have any Mountain Dew left.
That's it.
Oh no. I drank all mine this morning.
No.
You sure?
Let's make a trip to the store.
All done.
Beth Hart would have some diet Dew.
He's looking for his black whiskey. Yep. Empty one throws in the bin. Another one empty throws in the bin.
Okay, here we have a bunch much stronger acid. And the labels on this. Oh, nitric acid.
It's a good label it's got there.
We asked Manning if we could try his Pepsi.
Just walks in, takes it, pours a sample.
I would do that if I knew Manning was in a really good mood.
You want us to go scout it out?
So what is he gonna do?
If he was in a bad mood,
Well,
then I'd have to go talk him off a ledge later.
The window ledge outside his room. He's standing right there in the middle of the window.
Oh my god!
No.
There's only 3 people in this room. That's Tyler, Alex, Gibby. See what you did there.
Wow!
Wow.
Holy shit! And our toxic.
You can see a much different color change there. So when we
You only hit him sometimes.
put that there, we can see that that has a pH of 0.
What?
Caution may burn if touched.
Yes, this one we would not want to touch.
That's the burden through the whole world.
Okay, I think I've got a basic solution back here. We got
Basic. Basic. Basic.
Yes, that is it.
On a scale of 1 to get over basic.
Or my sodium iodide.
No, I'm gonna ask it.
You don't got any bleach back there?
I'm just thinking.
Or ammonia?
Oh, breach. Clean anything to touch your butthole.
I'm pretty sure he cleans that too,
Not if coming from inside. That's awesome.
but.
You did. Very did.
I was watching this episode where Lily starting to do a Chinese restaurant. And she's like, I'm not a Chinese restaurant. My dressers are fix my dresser. I just left everything there.
Oh, very good. Much fly waste for you. Extra dollars.
I guess I need to make some more calcium hydrate. Let's put that other one go.
Should pour all of that baking soda into the vinegar and see what happens.
I got bacon soda. I got bacon soda.
Correct.
Cocaine.
Correct, that's it.
So here we have a basic solution.
Oh, it's green.
It's very bluish. So there's actually a few different chemicals that are on here, because some chemicals are going to turn a certain color when they're in an acidic environment, some are going to turn a color when they're in a basic environment. And here, if we match this up, we can see this has a pH of about 11. Okay, so that's a basic solution. Now, pH strips are nice because they are easy to use, but you have to dip them in something. So in certain cases, that's not going to be very beneficial. We also have something called an indicator solution. Okay, so here we have phenolphthalein, which is an indicator solution.
It's supposed to turn red, isn't it?
You can see when we put it in the basic solution, it turns very pink. Right? So by putting that in there, we can see, ooh, this is basic. If we add some of the acidic solution to that, that's the nitric acid. We can see by changing the pH, the nitric acid and the base in there are reacting and they're forming more of a neutral compound and it turns acidic. Now, by
Neutral.
or neutral, well, we're probably in the acidic region here, of course. Now, if you're really careful about it and you measure how much goes in there, you can actually measure the pH of the solution by seeing how much you add, because the phenolphthalein will turn colors right at that neutral point. And later we'll do a titration where you will actually set up and you will put stuff in there until it changes color and stays the basic solution. And then we can measure the pH of an unknown solution.
So what you're saying is you still don't want to drink that.
Right? Well, need to put some more basic graphs. We can keep adjusting the pH back and forth. We didn't put too much acid in there. Get it back to the color. Oops. Get a little carried away. The nitric acid's pretty strong. But anyway, an indicator solution is another way of measuring pH. So you've got pH strips, indicator solution. There's different indicator solutions that can be made for different pHs. Another thing that we'll do next week is you guys will actually be making pH strips out of coffee filters and red cabbage. Red cabbage.
What? Non-existent.
This.
For college speech.
I have like my first paragraph of my
I don't have anything
written.
typed out.
I would
Me neither.
Mine's are, yeah, mine's are, that's it. Did you say she's just going the legal one?
Wait, we have to present them on Monday? I thought I thought the outline
Monday, Tuesday,
was-
Wednesday.
Well, your outline is on Tuesday.
Oh.
This weekend?
That's not really foil.
I'll probably do one on that.
No, it's Whatever.
Okay. Another thing that we can use to measure pH is a pH probe.
Wow.
So the way a pH probe works is it actually measures the conductivity, the electrical conductivity of the solution. And by looking at how the electricity is able to flow between the two probes, it can measure what the pH is, the amount of dissolved ions that are in the solution. Only problem with those, they're kind of expensive.
Yeah, why don't you have them?
Is that, we do have one. I have not, I dug it out of a drawer last year. Don't know how well it works. There's solutions that hold it dry. But it has solutions that have to exist in the probes for the conductivity to work. Well, I haven't had time to play with it. That is another way. And of course, this is nice because it gives you a much more accurate thing instead of going, oh, that's about 11 or about 6. It will actually give you a measured pH. So these are more accurate. Of course, the problem is they're expensive. And those are the three main ways of measuring pH. You guys,
Figured out an A.
what's that? Okay. So you guys will be using the pH strips and titrations. Whether we break this thing out and use it, we'll see. Well, what I'd like to use it for is when you guys do your titrations, and you calculate what your pH is of the solution, take it over there and check it. That would be the thing. That's pretty much all I got. But of course, we're going to have some.